On-premises clusters are just as important in Spectro Cloud Palette as cloud-based clusters. With support for bare metal, VMware, OpenStack, and Nutanix platforms, customers can select from a wide range of supported options to satisfy their on-premises Kubernetes needs. Especially with the rise of AI and hardware-accelerated use cases, the need for Kubernetes on bare metal has been rising fast. Spectro Cloud Palette helps customers get the most out of their private data centers. Palette supports two approaches for on-premises deployment: Cluster API, or CAPI, and non-CAPI. Deployments with MAAS, VMware, OpenStack, and Nutanix are all based on CAPI and provide a similar user experience as with public cloud platforms. You will simply define the cluster size and specs, and the Cluster API provider will create a cluster with those requirements by orchestrating the resources of the chosen platform. Adding more nodes to a cluster is as simple as increasing the node count on the worker pool. CAPI will take care of spinning up additional VMs and joining them to the cluster. For a more hands-off approach, you can enable the autoscaler feature and let the cluster decide when it needs to adjust the size of the node pool. In the case of bare metal servers, Spectro Cloud wrote a Cluster API provider for Canonical MAAS, with robust capabilities for setting the desired network and storage configurations that are leveraged by Palette. Through the MAAS provider, bare metal servers become a dynamic pool of capacity for building Kubernetes clusters in a completely automated way. For VMware clusters, Palette provides support for both static and dynamic IP addressing of clusters. Customers can either define a pool of IP addresses that Palette will manage to statically assign to cluster nodes, or configure DHCP with dynamic DNS to let the network assign IP addresses dynamically. Customers can set CPU, memory, and disk sizes for the VMs directly from the cluster deployment wizard. Cluster API is a wonderful technology, but sometimes it may not be the best choice for the use case. For example, Cluster API does not exist for edge clusters, and some storage and networking technologies are not compatible with Cluster API, like the OVN-Kubernetes networking used in NVIDIA's Bluefield DPU accelerators. For scenarios where Cluster API isn't the right approach, Palette provides appliance mode and agent mode as solutions. With appliance mode, customers run our immutable Edge OS, which includes a management agent that registers it with Palette. With agent mode, the customer can use any existing OS and simply add our agent to it to enable the same registration with Palette. From there, the customer can build Kubernetes clusters in nearly the same way as with Cluster API, with the only difference being that the customer now picks the nodes that will form the cluster. The management experience remains almost exactly the same, so customers can run clusters with or without Cluster API without any downsides. Speaking of Edge, Spectro Cloud remains a leader in Edge cluster innovations. Palette's flexibility for Edge has enabled customers to go beyond the limits of Kubernetes of the past, with production examples ranging from AI inferencing in hospitals to 3D oral scanners in dentist offices. Edge clusters can often operate in remote, insecure, and uncontrolled environments where corporate IT may not have control over things like network IP addressing, firewall rules, or even physical security. Solving for these problems is where Palette absolutely shines. Palette agents connecting back to Palette only use standard HTTPS traffic, which is typically allowed through most firewalls. Palette can tunnel an SSH session back over this connection to provide emergency remote SSH access to devices for administrators, even when the network is uncontrolled. Edge clusters support an overlay networking mode, which runs the Kubernetes cluster on a dynamically created VXLAN network between the nodes. This allows edge clusters to operate in foreign DHCP environments where IP addresses are not guaranteed to stay constant. Even if the DHCP address changes, the virtual IP address on the VXLAN network stays the same. This technology even allows customers to pre-build clusters in one location and then ship them to a different one for production. The Spectro Proxy Pack allows interactive remote access to the Kubernetes cluster for administrators, leveraging similar techniques to get around firewall and network restrictions. We integrated this technology with the Kubernetes dashboard so that customers can visually interact with their edge clusters no matter where they are. Edge clusters can be deployed with an immutable OS in trusted boot mode. This enables secure boot in the BIOS of the device and encrypts the contents of the hard drives. The encrypted drives are only unlocked if measurements taken during boot prove that the system has not been tampered with. Edge devices provide a web interface for local management, even allowing the deployment of entire local clusters without needing Palette. This provides a friendly and familiar user experience for deploying air-gapped clusters. Since every edge cluster can manage itself, the connection with Palette is relatively lightweight compared to other solutions in the market. Tens of thousands of clusters can be managed with a single Palette instance, which is orders of magnitude above what competitors can muster. As a result, customers that need to deploy edge clusters in large quantities all choose Spectro Cloud Palette. Palette's abstracted management UI provides the same experience for Day 2 management among on-premises clusters as it does for cloud-based ones. OS patching, OS upgrades, and Kubernetes upgrades are all seamlessly handled. During cluster API upgrades, Palette will rebuild cluster nodes one by one, evacuating workloads as needed to ensure application uptime isn't affected. We even provide an optional node repave interval to add arbitrary pauses between node rebuilds. This is a highly useful feature for hyperconverged clusters, for example, running Rook-Ceph or Portworx Enterprise, where such storage solutions need some time to fully initialize on fresh nodes and properly synchronize with the rest of the cluster again. With the node repave interval, you can set a safety margin to ensure every node rebuild happens at a safe pace. For edge clusters, upgrades happen in place, providing the least amount of disruption during maintenance. Palette continuously monitors node health and will automatically remediate unhealthy nodes. Customers can also set their own geolocation tags on on-premises clusters, helping to create an intuitive map of cluster status across the globe. When the on-premises platforms such as MAAS or VMware cannot be reached directly by Palette, for example, when the customer consumes Palette as a SaaS platform, they will deploy a private cloud gateway into their on-premises environments. The private cloud gateway mediates the connection between Palette and MAAS, vCenter, or OpenStack so that no firewall changes are necessary for the customer. The private cloud gateway is only used to deploy the first node of each cluster, after which the management components are moved from the private cloud gateway into the target cluster itself. This way, running clusters have no dependency on the private cloud gateway after the first node has been installed. As with public clouds, cluster profiles are the core of cluster management with Palette. While infrastructure profiles will be specific to each target platform, either in the cloud or on-premises, there is also the add-on profile, which is platform agnostic. That makes Palette ideal for managing clusters across multiple platforms. Common components for all clusters can be managed through a single add-on profile, giving you centralized control over versions and configuration. On-premises bare metal clusters are also the prime target for Palette's latest offering, Virtual Machine Orchestration, or VMO for short. With VMO, customers can deploy a platform for unified management of containers and virtual machines. Based on a combination of KubeVirt, Multis, and other technologies, VMO delivers a platform for virtualization that closely resembles vSphere Enterprise in terms of features and performance. VMO has already proven highly valuable for customers that are looking for an off-ramp from VMware, as migrations from VMware to VMO are now underway.